Hello, this is section 7-3, and if you'll notice, I made a mistake there, because sometimes people make mistakes. When I did the print, it actually did 7-2, so I apologize for that. But everything else should be okay. In this section, we're going to introduce the idea of logarithmic functions and what a logarithm is. Logarithm is a noun, logarithmic is an adjective, but it's the same idea, okay? So I cut and pasted this from the book. That's why it's a little pixelated and everything when I blew it up. But this basically gives you the idea. So have this nearby. Pause the video if you want and write this down. It's also, like I said, it's in the book. And if we were in class, I would have it up on the board so you know what it is. In Chapter 7, Section 1, we talked about exponential functions. And in this case, we have an exponential equation. All right. An exponential function, just to show you the details, an exponential function is where I say y equals b to the power of x. This exponential equation, like all equations, is where I take an expression and I have it equal to another expression. So in this case, if I put some, I already know what b is. B is not a variable. B is a number. Sorry, it's a constant. My mistake. And b has to be greater than 0, which means no negatives, and b does not equal 0. And also, we don't let b equal 1, just because that's trivial. The x is the independent variable. The y is the dependent variable. What this exponential equation is saying, hey, what happens if you know what a is? And that's really, really important. So y equals some number a. And just like we said, just like we said for b, a is not a variable. It's a number, okay? It's a constant. I said that twice. I'm not going to start my video over again, okay? Now we're going to reverse all of this. So if you know what the result is, if you know that this y equals a, but you don't know what the x is, we're going to work backwards and figure out what the exponent, which is represented by the independent variable, how you got that. So let's say we start off with this exponential equation. And they wrote b to the x power equals a. I could have wrote a equals b to the x power. Those are the same. It's an equation. This can be rewritten as a logarithmic equation. And it gets a little tricky with talking about logarithmic functions, so just stay with me. I'll bring that up too, all right? Because again, the section is logarithmic functions. Why are we talking about equations? Why are we talking about functions? We'll get to it, all right? So where does everything go? Well, first of all, the b, which is the base of the exponent, which is a constant, see, I got it right that time, becomes the base of my logarithm written as a subscript. So we write log, and we put a little b down below the line. That's called the subscript. Now, since the input or the independent variable is x, and the output would have been y, which in this case we know what it is, you know, like it's y equals 7 or something like that, that number becomes the input. And then, of course, the x, which is the exponent. So the trickiness comes from section 7-2, because in that section we talked about inverses. That's where we discussed switching the x and the y to make an inverse. So if I had a function, I say y equals b to the x power, like we did in section 7-1 the first time we got to chapter 7. Now here's the deal. With this function, we write y equals log base b of x. And I put my parentheses around it. Excuse me. Not everyone does, all right? Functions that use names, I suppose, and we'll see this when we get into trigonometry, sometimes we get lazy, we don't put parentheses around it, and we should. So anyway, but the hard part about talking about both these at the same time is that y is not that y, and that x is not that x. These are inverses of each other, And when we talk about inverses, that means that we actually switched the x with the y. All right, so don't panic too much about that. I think sometimes, like, and it's like we can get by with just understanding what's going on, but it's sometimes we think too much about it. All right, and there's some deep math here, but just more than I can get into in video. It'd be a good conversation for having in class. But all of that is just to be able to convert from exponential form to logarithmic form. And I know it's, don't worry about the formatted, okay? So I'm gonna write this again. So if I have b to the power of x equals a, then this can be switched back and forth with log base b of a equals x. So each time I have 2 to the power 6 equals 64, 4 to the power 1 equals 4. These exponential equations, they're all true. 5 to the 0 power equals 1. 5 to the negative 2 power is 1 over 25, which is 0.04. They gave it to you as a decimal. And then this one, we use a variable. So we're going to talk a little bit about this one because this is getting to the main idea. I just want to rewrite these in log form. So I write the word log, that tells me I'm going to use a logarithm. What's the base of the exponent? The base of the exponent is 2. So I write a little subscript 2 right below it. And I didn't look this up. I didn't like explain this really well, but go ahead and Google that, look it up, what a subscript is, okay? So the 2, which is the base of the exponent, just we write it right here. We call it the base of the logarithm. The bases are the same. Now, the exponent is what the whole logarithm equals. So I'm going to write that in a second, but I got to do this part first. I'm going to put 64, and then that equals 6. So the 2 becomes the base. The exponent is what the logarithm is. By the way, I'm going to write this down. I'm going to say it over and over again. The logarithm, I'll say the logarithm is the exponent. If you remember that, you won't get into trouble, okay? The whole point of doing the logarithm, I guess I should have said this at the beginning, the whole point of doing the logarithm is to find out what the exponent is, and I'll talk about that when I get here, all right? Because in this case, we don't know what the exponent is. For this one, the base is 4, so I write log with a little subscript 4, log base 4. This 4, and I know it's confusing because you got 4 in a couple places, I'm going to put in parentheses. And what I'm actually getting to is 4 to what exponent or to what power equals 4. And the logarithm is the exponent. For the other one, this is saying 2 to what power, what unknown power equals 64. Well, that'd be 2 times 2 times 2 times 2 times 2 times 2. So there'd be an exponent of 6. For the third one, my base is 5, so log base 5 of 1. So 5 to what exponent equals 1? And as we know, that's going to be 0. And notice every time the exponents are 6, 1, 0, the whole point of doing a logarithm is to give me the exponent. The whole point of doing logarithms is to simplify, I don't know, simplify, we use simplify in a different way, to make understanding things that grow exponentially a little bit easier. And we're going to be seeing lots of examples of that. The couple of them that come off right off the top of my head are pH, which measures the acidity or basicness of a solution, and another one is magnitude of an earthquake on a Richter scale, and also another one would have been like decibel level. So you're going to be seeing examples of that. That's where the numbers get so big that in order to understand it, we write them on a logarithmic scale where we look just at the exponent. And I'm not an expert at this. I'm not an expert at any of that, but I think resistance in a circuit also uses powers. So anyway, let's do the next one. The base of my logarithm, again, I'm sorry, the base of my exponent is 5, so the base of my logarithm is 5. 0.04, so this is saying 5 to what power equals 4 100ths, or 1/25th? And that's going to be -2. And then finally, for this last one, this is where we're headed here, where we actually have an equation that we want to solve. I say the base of my exponent is 3, so I have log base 3. This gives 81. Sorry, that gave 81, so I'm going to put 81 into my function. And this is going to be x. So I say 3 to what power equals 81? And when I see a logarithm like this, and this will be in the next video, when I see a logarithm like this where I'm not given the exponent and I have to figure out the exponent, sometimes you can do this in your head, go back and convert it to the exponential equation and say, all right, 3 to what power equals 81? Okay, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So I would follow this up with x equals 4 when I saw that. Okay, in the next video, we're going to give you these, and we're going to switch over to these.